Welcome. My name is Alec Pinkham. I'm excited to present this Academy session on some tips for troubleshooting Microsoft Teams, as well as some other examples of what this looks like in practice, right? The challenge that everyone has had, and we are all here to talk about, is poor performance in meetings, right? Choppy video, poor audio, constant apologies, or sending chats from your phones that you'll be right back, right? I also can't stop this from happening, right? But what Broadcom software can do is help you figure out what happened, where it happened, and who can fix it, right? So I've mined some of the best practices from our customers, as well as included some of the functionality that AppNeta by Broadcom software can bring to the table for this problem. So for better or worse, meetings are essential to business, right? In part due to the pandemic, but also in part necessity, right? Virtual meetings have become the norm. And even back in the office, they monopolize the most calendars, right? If you use Google Calendar, you can see they actually built a tool to calculate exactly how much of your week is spent in meetings, right? I think one of the core issues is that with the shift to hybrid work, there are fewer side conversations happening in the office. Depending on the culture, I can either chat you, email you, or just book a meeting for your time and set that time to talk about a specific topic, right? We're at the point where analysts, specifically Gartner in this case, thinks that only 20% of meetings will be in person in the future, right? There are studies on how turning off your camera can help with fatigue. And our own study that found that one of the largest frustrations over the past year was technology disruptions within those meetings. There are a couple of other shifts that I want to talk about here. The increase in hybrid work is part of the first stat around that number of meetings that will happen in person dropping. But with this stat, there's almost 70% of companies that are operating in a hybrid environment today. And about 30% of them, or almost a third of them, are planning for permanent hybrid. And that supports the need for IT to plan for either heavier in-office traffic due to those internal and external meetings requiring virtual attendees, or planning to support employees that are working from home and need to have troubleshooting for their own networks and their own applications there, right? People are used to video conferencing, and it definitely affords some benefits, right? It's less disruptive than physically moving to a new space if you're in the office, right? Often with a laptop in tow, coffee in one hand, notebook, mouse, something balanced on top, right? It's easier than connecting up to a presentation hardware in a meeting room. But regardless, even in office meetings often will have remote attendees. We can talk about Zoom. We can talk about the Zoom takeover for non business conversations that bled over into work as the Zoom platform matured. And Zoom's features that actually pushed companies like Microsoft to make Teams better and pushed other solutions to make theirs better as well. And what was heralded as this shift towards cloud hosted video conferencing, it became essentially the norm, right? The distributed user base of hybrid work makes this almost a necessity. But what we learned is that performance is variable. Depending on the region, user habits, Wi Fi versus wired, in office, at home, right? You see a lot of different performance, right? You see guarantees of 99% uptime for Teams as part of their SLAs. Anyone who has ever leveraged Teams or any other video conferencing solution can probably attest that uptime doesn't actually necessarily equate to optimal performance, right? It means the app is running. It doesn't mean you can access the app or that your traffic stream is supported and you're actually getting good connectivity up and down. Understanding performance in these cases is difficult, but let me walk you through a little bit of how Teams works to help us understand the performance side. So a little bit of background. The Microsoft Teams architecture is by design a black box, right? Microsoft does a good job in running it, and the architecture is well thought out, but they may have taken a number of steps which limit your ability to directly monitor the performance and availability of Teams, especially from the employee perspective. Right? We work extensively with Microsoft and their customers in monitoring Teams performance, and there are a few things to understand that impact performance of Teams for your employees. Right? There are currently 38 regions around the globe that host Teams calls, right? And the one that's geographically closest to the organizer of the call will be the host, right? All of the others will connect to the Azure region that's geographically closest to them. And once connected to that point of presence, the team's traffic will transit over the Azure backbone to the host region. Right, as you might expect, Microsoft runs a very high performance backbone between its Azure regions, but the determination of which region each user connects to is handled by a separate global network of Anycast DNS, right? And that works well. But a challenge is that they also have a specific Anycast address that they provide for customers to monitor for testing performance and availability of teams. The issue here is that, that is one global Anycast address for monitoring, and you'll target the one in the closest POP to you. But because of this matching of the team's region to the host, that might not be the one that you're actually getting your team's call hosted from. So the AppNeta product has planned for this and has a global network of targets in Teams regions. And this enables you to specifically target the region or regions that are hosting calls based on your company's locations. And as your target is running our monitoring point software, it provides complete performance visibility in both the upload and download legs of that connection. Right, this setup actually tests the complete end-to-end application delivery path, including local Wi-Fi, the WAN connections, your last mile ISP for work from home employees, if you're in the office, your corporate ISP, all the way into the Azure region hosting the calls in question. Right, that gives you that complete visibility to find and fix problems no matter where they're occurring in that delivery chain. So with a globally distributed service like Teams, not every user experience is going to be the same. Right, this architecture affects the users in the office as well as at home. But let's take a look in the office to begin with, right? Predominant trend we've been hearing is a reluctance to use meeting rooms, either because of pandemic policies or employees are used to multitasking at this point, right? That leads to usage above and beyond the expected, potentially pre-pandemic levels and needs for enterprise networks, right? The number of people who, instead of attending a town hall meeting or a big company meeting, just call in from their desk means you're going to have a lot more traffic on the internal network, right? Prior to the pandemic, during many, many offices using business class direct to internet, right sizing based on the office populations before has to be reevaluated now that we're in, a different part of this journey where we're not sure how many people are going to be in the office or the policies continue to change, right? Networks aren't exactly falling over, right? We have fewer people oftentimes, but we have a different makeup of the traffic, right? The change in behavior is one that IT has to monitor and understand as they change policies for the future, right? And this is supported by the Gartner statistics that I talked about in the reduction in spending on in-office meeting room devices. We've seen a reduction in the number of people attending meetings in person, right? And at home, you're dealing with connectivity challenges. Either the ISP links are under provisioned for the home. They're often asymmetric, which is, fine for Netflix and download because of the download priority. But for apps that use both upload and download, most basic plans are barely sufficient to allow a couple different streams at the same time, let alone the normal workday load plus potential congestion in local ISP links. Right, our own IT actually ran a bit of a survey to start the pandemic to understand what people were paying for and expecting from their ISP, and then providing advice, allowing them to easily troubleshoot and help us out, but also understand, what we're paying for might not be sufficient for what we're trying to do. So for users with insufficient bandwidth, they may have had a conversation around upgrading or switching providers. Now, by having data across the employee base, we're actually able to see which regions had better vendors to go with, right? Many of the enterprise that we've talked to have created policies around requiring wired connections in the home. AppNeta can actually show this connectivity at the highest level just to isolate if users are reporting issues when they were on Wi-Fi, but then turning to wired when they contact IT, right? So maybe they were on VPN, but they disconnected, and that's causing problems, right? Being able to see their connectivity is a big part of this. But this really brings up the trust but verify approach so that IT doesn't have to guess at how users are connecting. Now that we've talked about the shift we're facing, the challenges, let's get to some of the fun stuff, right? Solutions, metrics, and how we can troubleshoot these issues. So when we're thinking about performance and we're thinking about monitoring, there are a couple of angles we can approach from. We can approach this from the traditional monitoring, the infrastructure in the top left, right? The pros of this are obviously these are own devices. We can fully observe them. Oftentimes we can touch them or at least configure them by remoting in. If something is down, it's fairly obvious when we have, things like SNMP or reporting, we have heartbeats. But most often, those problems are fairly easy to resolve, and those are usually baked into traditional monitoring tools, traditional monitoring, network operations center type screens. The cons here is that with more and more of the apps that we're using being cloud delivered, and with more people being in different locations, we have less and less visibility. So infrastructure monitoring only gets you so far. It is very important for data centers that we own, headquarters office environments, but it's very important for the networks we own. But that is a shrinking percentage of the actual application delivery paths between applications that are business critical and users that are using them. On the top right, we can look at cloud platform performance, right? Typically, these are run very well. They're resilient, they have redundancy. Maybe they're using CDNs, but this is essentially the top applications. If you're using some smaller ones, maybe you don't have all of those benefits. You only get so much when it comes to things like status reports, uptime, right? As we mentioned with Teams, the uptime guarantee just means that the servers are available to the internet or available to regions of the internet. It doesn't mean end-to-end performance or end user experience is good. In the bottom right, going clockwise, we can also look at voice metrics. Call data records, CDRs, right? Great records of actual calls can be excellent for troubleshooting reactively, right? Once an issue has occurred, we can look at that data. Great for when you're setting up a network and you want to see if that initial setup is correct and can handle calls. But there's no way to be proactive here. There's no way to understand when performance is trending in the wrong direction via a CDR, right? Unless these are active meetings, we need to make sure that we're testing this on going so that we can get continuous metrics. And finally, the WAN performance, right? This piece is crucial for cloud and web apps that are delivered via the WAN because it's not only one of the largest components of the application delivery path, it's often the most dynamic, and it's often the one you have the least visibility into, right? You need active monitoring to get visibility into this, right? Otherwise, again, you're relying on the picture at specific ingress or egress points, and it's difficult to understand where performance degraded if it's somewhere in the middle, right? So as we're looking at mainly cloud-hosted conferencing solutions, in this case, Teams, right, what are those top considerations that we can look at when it comes to performance? Right? These techniques are what I want to cover, right? They help you understand the scope when issues occur. From our experience, the top considerations are really around what ability do you have to see bandwidth and capacity? Can you identify transit quality? And what analytics do you have available around end user experience? Right? With bandwidth and capacity, there are a couple things to look for, right? In the enterprise network, we need to assess how the paths have changed with the new cloud hosted model, right? Where does traffic exit or egress to the internet or to your connections? What new access points are needed? And how is that going to change over the future, right? If policies are in place, if we're doing transformations, things like SD-WAN, are we split tunneling an app like Teams out, right? We need to be able to make sure that that gets to the internet quickly if it's a trusted app. Right. I also want to mention something about kind of habits here that we talked about before. Specific employees using meeting rooms, right? How can we estimate concurrent usage for these facilities and the aggregation at internet access points of how many calls are going through those locations, right? Sizing the internet access, determining performance of firewall and traversal there is going to be a really important piece, right? Managing competition with other applications using those same internet access points. If we have data intensive applications that might spike at certain points of the day? Do we want to make sure that those are split out outside of meeting times, right? We can look at VPN overload, right? With everyone working from home or everyone connecting from outside of the traditional office environment, are we backhauling traffic into the office for specific applications, maybe internal apps, or maybe that is the connection that we have the best transit to another office or a data center that's hosting internal applications? We want to look at that. From the transport quality perspective, we're looking at managing end user experience, right? We're measuring the known good values of loss, latency, and jitter. Right at the enterprise level, we need to verify if quality of service is in play and working properly within the enterprise. If we're marking inbound traffic, prioritizing outbound traffic, things like that. We can look at reduced competition from bursty data applications, as I said before, and that can affect transit quality. So we need to look at moving schedules for backups and understanding generally what that load looks like. We also, again, want to look at loss created by either firewall traversal or other security in place, like IDS. Internet paths to Teams access points is another big piece of this, right? How many ISPs are in that path? Do we have upstream peering providers that we need to look at, right? We need to look at the performance and stability of those paths, right? If we want to consider something like MPLS or SD-WAN to improve performance, how does that interact with something like Teams, right? I mentioned split tunneling earlier. For trusted applications, oftentimes you want to go direct to internet for the large SaaS that have either replication or the ability to limit latency based on region. Otherwise, you're putting a lot of people in the same box, even if they could get better performance going from the internet. And with work from home in there, right, in-home or remote office traveling employees, right, Wi-Fi performance is going to be one of the biggest ones, considering policies around hardwire, power line extenders, or things like that for the home, right? And then the quality of ISP, right, mandating or at least helping the user and the employee understand the language around whether or not they need to get an upgraded internet connections. And of course, don't forget the quality of the laptop, right? Cameras that are better are going to have better pictures. There's good compression, but we need to make sure that we have good connections for all of the hardware devices that are involved in this. The final consideration here is analytics, right? Managing the quality of experience over time, right? Getting a consistent set of data on path quality with metrics around capacity, loss, latency, jitter, time of day, locations, geography, specific Azure connection points. Like looking at all of this in one place can be very helpful for understanding where performance is dropping and how we can actually impact it on IT. And I want to harp on locations because that can be a sticking point, right? Many of us do work in different geographies. We work with teams spread over the globe, and that means varying connectivity profiles, right? Determining the appropriate threshold and measuring paths against that standard is going to be the important one. We're going to have different tolerances for these metrics, right? How do we manage quality for users going directly from work from home offices to teams when that's somewhat out of our control? And the question is it out of our control? And no, not totally, right? We can instrument our office and measure office to cloud performance, right? This path is kind of the most under your control because it's coming from your office environment and you have spent time doing capacity planning and understanding the connection to the greater internet from the office. So it gives you a little bit better known networks and providers. It also represents performance to which office-based users are accustomed. So that's a little bit of a comparison that we can use. And we can use thresholds that will flag problems that are worse than average, right? On loss, latency, jitter, things like that. The way that AppNeta can test is also not specifically just data traffic, but also voice traffic, looking at the different packet kind of ordering, sizing, all of that to kind of match what the voice traffic looks like. We can also measure from work from home or hybrid environments as a comparison, right? The thresholds on those are going to determine which users are getting good or poor performance. It'll allow us to do better comparison, right? Individual user challenges can be debugged using hop by hop statistics from AppNeta. But grouping users can also be very helpful if you can group them on common geographies or common data centers. So if they're all going to the same Azure point, or if they're all connecting to the same Azure POP and maybe having some transit problems, right? Or if they have a common last mile internet provider. If there's a specific provider that maybe not as well suited for this. And then, of course, you can isolate to individual problems if you have this testing across the board. When we're looking at this, we also want to look at the size of the group affected, right? Rank in the organization can come into play if it's, someone who complains a lot and they happen to be on the executive team, but understanding priority based on specific groups that maybe have more reliance on web apps or more reliance on cloud delivery could help your IT team troubleshoot a little bit faster when it comes to regions and departments, right? But at the end of the day, hop by hop analysis can help kind of convince either the user or the service provider where the problem is and can provide the data that allows you to get that problem solved, whether or not it's you solving the problem or whether or not it's providing data for someone else to solve it. Getting the right person focused on solving the problem rather than trying to just blame them is obviously a faster way to get to the resolution. So now we understand the scope of the problem from a regional perspective. Let's say we've identified an issue to be location specific, right? One of the valuable approaches that we can do is attempt to isolate the problem further into specific error domains. If you can identify the area where the issue is originating, right, troubleshooting is going to be much simpler. The actual steps used in resolution will vary dramatically based on the level of access and control that you have over the area where the problem is occurring. And there are 4 really macro problem domains. So I'm going to work right to left in this case, right? If it's in the application hosting infrastructure, right, this will be pretty clear from the data that we can show previously. An issue with a service or a common infrastructure would be observed from many locations at the same time concurrently. We'd be able to see that it crosses across geographies or crosses across, a smaller geography, but it's every path that's pointing at that specific target. We can look at the mid-path network, right? This is where correlating performance with the route in use is key, not just the route as we understand the upstream providers to be, but the specific route at the specific time that a problem was reported, right? So we can identify if issues only occur with specific AS networks that are in use, or we can see a route change right before a problem is reported. We can also look at the user's last mile ISP, right? Are they getting what they paid for with the residential internet connection, and is it sufficient for the application, for in this case Teams? We could also look at the user environment, and this could be the office, wireless access points, traditional wired connections, and good visibility into the devices where we have a little bit more control over what we can do. But it could also be the home environment, where IT has to find out if users are on wireless or wired, right? Look for connectivity statistics. What else is sharing that Wi-Fi? What are the different devices in place? Are they using a very old wireless standard and also, trying to connect from the basement, right? Or did a user's backup kick off and bring the rest of the connectivity to a screeching halt because of congestion, right? This end-to-end visibility is sort of dependent on an active testing methodology. We have to be sending traffic out over the network to understand what the network looks like over time. We can't just wait for a problem to occur and then try to get the data afterwards. Finally, one of the things I'll mention is in order to do this, we have to have a low overhead approach. We have to make sure that we're not impacting the network that we're monitoring. So in this case, having the instrumentation to allow us to gather this data without impacting the network is crucial, right? Common tools like iPerf, speed tests, even some other commercial testing products, right? They measure performance through flooding or pseudo flooding, and that's going to disrupt the applications that you're actually trying to ensure or assure the performance of, and that's obviously not acceptable in this case. So the patented technology that AppNeta uses, that I'll mention a little bit later, has extremely low overhead, and it's meant not to impact the user experience of any environment. When we're addressing performance, we have to talk about metrics. When AppNeta first started, we focused first on real-time apps because they're harder, right? They're less tolerant to a jump in these metrics. So we wanted to make sure that if we could understand what it looked like for real-time applications, voice, video type communications, then we can certainly understand what data looks like as well. Data via TCP, it's more fault tolerant because of guaranteed delivery. But when we're talking about voice packets and the unified communications, essentially, we're dealing with a different type of traffic, and it's going to behave differently over different networks, right? If we put real voice packets, including a SIP stream out on the network to understand the data, we need to understand both the data plane and the control plane from that side. So there are different thresholds for all of these metrics, but we do need to measure these four, right? We need to understand capacity, latency, loss, and jitter from all of these specific to voice, right? By taking an active approach, we can take matters into our own hands and really ensure that we have the right infrastructure between our offices and our users and teams, right? And the last thing is that there's some value to mean opinion score, love it or hate it. Mean opinion score can provide a baseline to compare against over time, right? When it comes to voice performance, what is, good loss, what is good jitter latency, especially if you're looking across a global footprint, it may vary depending on the user and depending on where they are. So setting alert thresholds and reporting on MOS can create sort of a uniform metric here, right? If we talk about the fact that cell quality and call quality has improved over time, we could at least look for drops in that quality or drops in that average quality. So by using active testing, we can actually get a baseline over time, right? So one of the things you'll notice in this video conferencing scenario is that traditional monitoring can only passively pull metrics, of course, and they're only doing it from one location, right? The remote network, right? Likely SNMP host info from one side, some connectivity metrics, both outside of CPU issues or traffic congestion at the interface. There's not much else you can troubleshoot, especially when tickets come in hours after events actually occur, right? CDRs can be available, but it only gets the VoIP portion of the call, and more importantly, it requires a user to be impacted before you can actually detect issues. And generally, more than one would have to be impacted before it really gets your attention, right? Two of the big requests we've heard from our enterprise customers over the past year have been, how can I gain end-to-end visibility into network and app environments, specifically ones that I have no control over? And so in this case, ISPs, WANs, things like that, cloud networks especially. And then how can I diagnose performance issues to speed up resolution, right? One of the hardest parts about these is that IT has essentially been drafted into the position of troubleshooting any issue, regardless of whether or not the network is actually a corporate network or just a user trying to connect from home. And so the key here is active monitoring, right? When you can monitor continuously, you can be a bit more proactive to the way you approach end user experience, right? Namely, you can see when performance is degrading, right? Not just when it's already impacted a user. There's always a fine line between alerting early and getting noise, right, versus alerting late and getting blamed. But what's better is understanding when maybe a certain percentage or a region or percent of users monitoring a certain app gets to a point where you want to notice, where you actually need to take action, right? One person having an issue with an app might not tip the scales, but 20% of users in a certain region absolutely could. So if I return to those error domains that we see on the screen, right, we needed different approaches to fully isolate where an issue is, right? In the remote network, host, wireless wired connectivity, an agent on the machine, right? That's that kind of home, but also in the office to figure out what access point they might be going over if we have a problem with configuration. In the network delivery path, right, the agent on the machine targeting out and a responder on the outside targeting back can be very useful in isolating upload versus download issues. And that also will help us understand if the route is changing, IPs are changing. From the transit perspective, we're getting that general regional information, right? We can get some of this from inside out views, but we can also get some of this from outside in, where we're targeting from the outside of the kind of user environment and trying to access back in. And with the cloud, it's going to depend a little bit on the app, right? If it's an internal app, it's a very different story. We have some more level of information, but with Teams, right, we need that active monitoring to provide insight into the app service provider environment, into the Teams infrastructure. If you look at paths between any office and something like Teams, a majority of the hops on that path are going to be Microsoft hops. They're going to be load balancing. They're going to be, data center and cloud type networking that is in front of the actual Teams application. So let's dive into the data and kind of the insights that AppNeta can bring to apps like Teams by looking at our solution, right? I'll start by highlighting a few sections, and then we'll look at a live demo environment for a specific use case here. So let's first get a grounding in kind of how we're doing this and how we're getting the data, right? Let's talk about the ways we can get insight into Teams. And there are really two core ways that we're doing this, right? A global monitoring target or a global monitoring point. Global monitoring targets are AppNeta maintained, highly available targets that we monitor from essentially an internal environment to a remote site for internet connectivity. And we can do this 24/7, right? We monitoring remote site connectivity to specific Azure regions around the globe, including the regions that host Microsoft Teams. It's not every region in Azure that hosts Microsoft Teams. We support 1 or 10 gig, depending on what the location can support. But we also allow you to auto target. And so to simplify the network path configuration internally, right, we give you a generic GMT that is different from the generic monitoring point that Microsoft gives you, because Microsoft gives you one location across the globe, and we're giving you one that automatically targets the closest by lowest latency for Azure. And so it's going to find the closest one for you, and that's going to be the one that you're going to get onto the Azure backbone if you're not the host, or it's going to be the one that hosts the meeting if you are the host of the meeting. We can also do global monitoring points, right? Those are a little bit different because you can choose from 38 global locations to test outside in. So from the outside, from those locations to core locations or critical users in your own environment. And it emulates basically users accessing the hosted applications, and it monitors network health through that, right? We monitor performance to core public-facing apps or internet-facing services from those global locations, and that can be representative of your customer base. So if you get a general view of the app's performance from a specific region by using that, we can use that. And with global monitoring points, you can also compare performance of your apps across different regions before and after updates to identify if issues are occurring before your customers do. Okay. So we have a baseline on kind of the ways we gather this data with active testing using global monitoring as sources or kind of targets for monitoring, right? Let's start at the highest level. You want to have a baseline of performance over time. Specific for Teams, this is really important, right? In order to get service quality, we can look at the percent of time the service was good, had outages, or was violating that SLA for performance. And that SLA can be, something that you're kind of getting from the Microsoft team, but also focusing on what is going to be, proficient for your team, right? Again, Microsoft does a fairly good job of running Teams, right? So in this case, there's no outages reported, but that doesn't mean the users are having a great performance or having a great experience with these apps. So the report breaks down by location and sorts by the worst offending locations so you can prioritize that work. In this case, a large portion of the violations in terms of performance is actually Atlanta. You can see that kind of in the bottom left there. This is one way that we can baseline performance of apps like Teams. And I think key to this is to the location-based component, because we know that performance we're going to vary between location to location. So we want to make sure that we're looking at this from the critical locations that our users are sitting, but also understanding the performance over time. So route analysis, most troubleshooting will start with the app, but from alerts or tickets, you'll know an app, a location, or a user is having trouble. So you can dive in first with something like a route diagram, right? It helps you isolate where in the delivery path an issue might be occurring. It also alerts you to route changes or flapping that could exist. In this case, we're looking at a time frame of 1 hour. You can see there are many different routes that are taken, even from one specific location. And over time, that's going to change, and we can isolate and correlate that with tickets that are coming in, right? We can alert to those route changes as well, right? But it tells you, the network operators and the owners, what you're dealing with in terms of kind of a dynamic nature of these connections. Next, I want to highlight continuous monitoring. I've mentioned it a couple times today, and I think continuous monitoring is something that not everyone quite understands how we're doing it, and how it's beneficial, right? It makes sense. Like, having a continuous view of performance is better than a point in time view. The way that we do that is through a technology called TruePath. It's proprietary to AppNeta, and it uses packet train dispersion to send tests over the network every 60 seconds. It has a couple different levels. That means that using these alert thresholds, the black horizontal bars you can see on these charts, is that if the testing goes over that alert threshold, and based on that alert profile either stays in an alerted state or a violated state for a long enough time frame, then we're going to basically test again to confirm that the issue persists, and to understand if that issue is going to just be a network blip, maybe caused by a route change, or if it's going to continue and we have bad performance for a longer period of time. If we confirm the issue, we're going to auto escalate to a diagnostic test, and we're going to look at every hop along the way between the source and target and understand all of the metrics you see here, plus more. We'll look at this in a second, to essentially isolate where in the stage the specific metric spiked up, or where the specific metric broke the alert threshold. Right? This is network agnostic, right? We can get the end user perspective over any network, internal or external, because we are experiencing the network as a user would, right? This includes going from a device over their wired or wireless connectivity, and understand as that is changing over time, we can call out that the user got on VPN or went from wired to wireless. You can see that in something like the wireless statistics, to see that the wireless was potentially not very good, and you can see them switch to wired at some point, and maybe the performance gets better, and we can look at those breakpoints. Another specific piece here is that we're using it data and voice traffic, right? We talked about this a little bit before, but voice and video conferencing is made up of both, and we need to be able to track the different profiles over the network. So continuous monitoring is not only using kind of all of the technology that we have to test continuously at very low overhead, 0.5% of the actual network capacity, but we're also able to do it to mimic the actual types of traffic that you're going to need in order to do video conferencing. So as I mentioned, the diagnostic is kind of the last stage of the violation testing. So when TruePath auto escalates based on that alert profile, when we confirm that issue and it's a persistent issue, that diagnostic is automatically kicked off. You can also manually trigger these as well, but it gives us hop by hop insight into the path at the time of the issue, right? Not later, when things could have returned to normal. You can isolate the hops in this case. You can draw lines between the error domains I mentioned to show where loss is increased, maybe where MTU drops, if there's a change in network there. If QoS is set on a path, we'll also show what the setting was and if it was honored in the return data throughout the process for this. So in order to kind of look at this, I'd rather switch out and look at this in practice. So what I have here is the delivery component of AppNeta, and we're looking at the network path page. I've used our filtering to filter not only on AppNeta Teams targets, but also the city of Vancouver we have in the demo environment. You can see over the past 10 minutes, we've actually had a number of different routes and a number of different targets here. And some of these, in this case, Azure West, we can see that there are actually 3 different routes over the past 10 minutes that is going through here. You can see if I kind of hover over here, we can see that the network for this hop based on the AS, we can also see the type and the number of trace routes going here. But any mid-path hop that we see that's in blue, we can also see what network it's in. And I can actually switch to the network view, and I can see that we basically go from our corporate demonstration environment through Zayo and then into Microsoft. Expanding any one of those will show you that in the cloud, and specifically when we're targeting Teams, most of the traffic is going in the Microsoft environment, and that is primarily what we're concerned with today. Now, all of these are going to show the type of connection. In this case, we can see wired connection, that little Ethernet logo here. We can see it's both bidirectional, so we have up and down, and we can see the violations in the past hour, 8 hours, total capacity, and top-level metrics. Now, if I switch over to something like the network timeline view, I can see the actual data from this path. In this case, the upload and download. We can see over the past 7 days, I can look back and say, oh yeah, there actually was a change we made in the network that would have changed the capacity here. So that's not going to trigger an alarm. As you can see, this is planned. So we're looking at that. I can see, however, it did increase the amount of jitter at the same time. So by looking at that, I can see, clicking on that point, I can look up and see that point on the other graphs and see, yeah, there was actually an increase in jitter. So we might want to check that out. I can see in this case, I also have voice statistics. So voice loss and voice jitter, as well as mean opinion score over the past 7 days. I can see that generally we've had very good performance in this link. I can see that we almost pinged up to the 2% loss in Vancouver. And that's going on the outbound route. On the inbound route, we have a lot more variation. But at the same time, generally these darker line spikes are the maximums within the time period. If I zoom in on this just by selecting, I can see that by and large, the performance was quite good, and we had very short blips above that. And you can see that the mean opinion score actually mimics those spikes, and we can see that it dropped, but dropped very small. Now, in this case, we don't have a violation showing, but with the ability to go back to the last diagnostic, I can pull up the hop by hop view, in this case, the voice details, and I can see the last time we had a problem, which is actually September 18th. I can look back and I can see exactly where that problem started. So in the first couple hops, I can see these are my internal hops. You can see that through the 172.16 IP address. Within that, I can see the latency, jitter, mean opinion score was fine. But as soon as we got into the Zayo hops, I can see that the latency increased as we'd expect, but the jitter also started to increase as we got to the end here. I can also see that the round trip time is going up as we would expect, but I can see changes, and I can see generally in this case, as we got from Zayo to Microsoft, we had a little bit more issues to deal with. And so I can look at this hop by hop. I can look at it from the data perspective as well. And I can see every hop along the way that was taken at the time the diagnostic was completed. In this case, you can see it could only complete the outbound. The inbound diagnostics were not allowed, and that's because the monitoring point was not able to get connection. Switching back to the dashboard view, I can see that over the past month, right, September 17th to October 16th, the past 30 days, for the application Microsoft Teams in the US across these offices, I can see that our performance has been generally good. Now, we have a couple things that we'd want to point out. We have a number of times where the performance was violated, and we have specific outage times. So one of the things we want to look into is where's that location, what percentage of the time, and with that, I can actually go into the past that we just looked at, look for things that were wrong in Vancouver to understand why that it was violating 10% of the time over the past few days. And so we want to look at that specifically because it allows us to isolate exactly where our attention should be focused. So in this case, Denver, when are looking good, we can look specifically at the Vancouver office to figure out what's going on there. And so from the top level, we can understand performance, and we can dive down all the way to that diagnostic we just showed to give you the full gamut of Teams performance. So finally, I want to say thank you for joining us. We have a couple other sessions going on here at ONUG Fall, so please feel free to check those out. Or if you're here physically or virtually, you can check out our booth and get a demo and ask any questions that you'd like to. Thanks so much.